we have a helicopter. Draw our helicopter here. Pretty. Oh, nice. That's a really nice helicopter. Really happy with that. So there's our helicopter. It is 1,000 meters above the ground. So we know that its height above the ground is 1,000 meters. Remember, an angle of depression is always measuring from a horizontal line looking down. So here's our helicopter. We need to draw a horizontal line, and it's looking down at an angle first of 27 degrees. So if I go down 27 degrees, right down to the ground, here is the car to begin with. Nice. And then this car in 5 seconds, 1, 2, 3, 4, 5, ends up right there. It goes a little bit further. I'll show that by drawing a line a little bit further. And now the angle of elevation, or the angle of depression, is 25 degrees. Now it depends how you draw your triangles. Some people draw the diagram like this with 1,000 meters here. Some people draw 1,000 meters here. Both of them will work. However, if we draw it this way with the 1,000 meters as I did to begin with, notice that the angles aren't part of the triangles. But if this is 27 as an angle of depression there, this will be 63 degrees there because it has to add up to 90. And what always happens with an angle of depression is that an angle of depression from the top will equal the angle of elevation from the car's perspective. Similarly, that angle of depression of 25 will equal the angle of inclination, or the angle of elevation from the car's perspective. And this one on blue, if you measured this bigger one on blue, would now be 65 degrees. Now again, there are 3 triangles, but the one that's not 90 that we can't use whatsoever, I'm not even going to take the time to draw it out. I'm going to talk about the green triangle, this first one. Bring it down here. And the blue triangle, which is the bigger one. And bring it down here. I'm going to ask myself, what do I want to find? I want to find out how far the car travels in those 5 seconds. I want to find this little x there, that little section from one car to the other. I'm going to label everything I know on my triangles. On my green triangle, I know that this is 27 degrees, this is a 90 degrees, this is 63 degrees, and it was 1,000 meters above the ground. On my blue triangle, it was 1,000 meters above the ground. The angle of elevation is 25 degrees, and this angle up here is 65 degrees, and a 90 there. In order to find that little x, what's going to be helpful to find on my green triangle and my blue triangle? The base, the bottom. Are you okay? What letter do you want to call the base of the green one? Okay, what was the first one? Who said that? Who said it first? What letter? Did someone? Yeah. B. Okay. I just heard it. Okay, we'll call it B. What about the blue one? Do you need the base? W. Okay. Perfect. So we got B for the base of 1 because base starts with B, and W for the other one because that's where the woad would be. Maybe? I don't know. Okay, that's pretty bad. So the B on the green one would be right here. And the W would be all of this. Reminds me of a bad joke. You ready for it? How do you think the unthinkable? With an iceberg. Let's take a. How do you think the unthinkable? With an iceberg. Oh. Oh, I like it. It's a Titanic joke. Okay. Yes.
Speaking of funny stuff, my mom taught me a hilarious, if possibly, if maybe not the kindest, acronym for so
Okay. So let's go to our green triangle.
Okay, green triangle.
Do we have enough information to solve the whole triangle? Yes. So if we're going to solve for B, the first thing we have to decide is which angle do you want to use? 63 or 27? Because it's going to change which are opposite and which are adjacent. So we have to pick one. 63. Okay. So we're picking 63. Then B, which we want to find, is the opposite. And the 1,000, which we know, is the adjacent. So katoa, toa. We'll use tan. Tan of 63 is the opposite, which is our B, divided by our adjacent, which was 1,000. So multiply both sides by 1,000. And 1,000 tan of 63 is equal to B. So we go to our calculator. 1,000 tan of 63. Push enter. I might need this later, so I'll store it. Alpha B 1962.6. Awesome. The blue one. Do we have enough information to solve the entire triangle?
Yes.
Yes. So now we have to choose an angle.
Angle
25.
25.
We want to find W. W is
Adjacent.
the adjacent side. We know 1,000. 1,000 is the opposite side. So katoa, tan again. Tan of 25 degrees is equal to opposite, which is 1,000, over adjacent, which is the W we want to find. A little bit more work here because we have to multiply both sides by W and then divide both sides by tan 25. Again, are you okay if I do that all in one step? Multiplied both sides by W, then divided both sides by tan of 25, and this is what you'll get. Again, we can go to our calculator. 1,000 divided by tan of 25.
466.3.
I got 2,144.5. Make sure your calculator's in degrees. 244.5. So now we've got W, now we've got B. Looking back at our original diagram, we know that W, I'm going to forget those numbers, 21445, 2144.5, that's W. We found B to be 1962-ish. So if you want to solve for X now, X will just be 2144.5 minus 1962.6. And I'll go to my calculator. I have the 2144 already in there, so I can just go minus. The 1962 I stored as B, so I can go alpha B. Again, you don't have to do those storing things. You can type in all the numbers with all the decimal places and write them all out. This is a lot quicker. And so we get 181.9. What are we dealing with here? Meters, kilometers? Meters. Good. Because if it went that many kilometers in 5 seconds, it definitely deserves a speeding ticket. So it went 181.9 meters in 5 seconds. We could take that information, we could figure out how fast this car is going by doing some conversions in kilometers per hour, and then we could determine whether they should send this person a thing in the mail from the Winnipeg Police Department saying, please give us a donation of $500 or go to jail for 3 weeks. Something like that. We don't have any. Yeah. We don't have any helicopter speed traps in Manitoba. They do have that in Alberta. So this would be one way. Now you can see how they could calculate that. Just see a car at one spot, see a car at another spot. You've got your angles of elevation. They would have a computer program that has this all built in automatically with those two pictures, be able to find out how fast that car is going and whether they're not passing the speed limit or not, and then send them a ticket. Right, but it's only 5 seconds. So if you've gone, right, because you want to go for kilometers per hour. This is how much it goes in 5 seconds. So if you multiply that by 20, you'll find out how far it goes in a minute. If you change it to kilometers, it's 0.81 kilometers per 5 seconds. Times this by 20, you'll find out how many kilometers it goes by per minute. Times it by 60, you'll find out how many kilometers it's going per hour. So take that, times it by 20, and then by 60. 218 kilometers per hour. Probably need a ticket here.